Good morning, grade 10. I'm going to go over the RF5 targets with you, and this will be our last outcome for this year. So I'd like you to make sure that you take the time to go over it if you can and have your targets out to check them off. Number 1, for each of the following graphs, identify the slope, the x-intercept, the y-intercept, the domain, and the range. Okay, so let's start with the x and the y-intercept. So first of all, this is my y-axis and this is my x-axis. And I know this is not overly clear on your page, but each one of these lines in this particular one is worth 1. And if they don't really make it clear otherwise, that's what we're going to assume. So if we're talking about the x-intercept, we're at the 1, 2, 3, 4, 5, 6. It's crossing at the 6, and that's a positive. And the y-intercept is at the 1, 2, 3. So where does my line cross the y-axis? That's known as my y-intercept. Okay, so that's at the positive 3. Okay, let me just make this a little bigger for you. There we go. All right, so the other thing about that is that I could write my x-intercept like so. I could say that it's at the 6 and 0, and I could say my y-intercept is at the 0 and 3. And what you're always going to find about x-intercepts is that the y value is always 0, and the x value on the y-intercept is always 0. That's always going to happen. So this might help us when we write down what the slope is, because we want to write down what the change in the y over the change in the x is. So how is it changing from the y on the rise and the run? Okay. Now, generally we start with this one right here. We start with the one that's closest on the left. So this one right here was my 0 and 3, and this one is my 6 and 0. So how is it changing right here? Well, it's going down 1, 2, 3. And then it's going over to the right, 1, 2, 3, 4, 5, 6. So then we would say that that has a slope of -1/2, because of course 3 divides by 6 to give you a 1/2. It reduces to 1/2, and it's a negative. And you can tell it's a negative because it starts high on the left and it goes down on the right. And these are all negative slopes. Now, in terms of the domain and the range, this one was a little bit tricky. I wonder how many of you got this. So because it has the line connected, all my dots are connected, and because it has arrows on the end, then all we're going to say is that it can be any number. And so this is how I write it. I say, so my domain x can belong to any real number. So it's part of the real number system. And I do the same thing for y. Y belongs, this little symbol right here isn't actually an E. It's like it looks a little bit like an E, but it's a Greek symbol that means belongs to. So x belongs to the real number system is what that actually stands for. Okay, x belongs to the real number system. Boys, that's getting messy, isn't it, guys? Sorry about that. All right. Now this one over here would be different because this one has a beginning and an end. This is known as a line segment, as opposed to this one over here was a line. Okay, lines go on forever. Line segments have a beginning point and an end point. So when I do my domain and range, we want to kind of start there with that one for this one. Then it will be different. So we're going to say, okay, well, x can go as low as, what's this? -1, 2, 3, 4, 5. So it can go as low as a -5. But it's going to be everything that's going to be greater than that up to and including, because that's a closed dot. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to and including 10. So we usually write it like this. That's kind of the professional way to do it. So we say x is going to be everything that is greater than or equal to -5, but it's going to be everything that is less than or equal to 10. And it's everything in between. It could be, you know, a -4.75. It could be a 1.32, you know, all those little numbers in between. So, and then my range, the very lowest it can go is a -2. So we'll go y such that, or y can be -2. It's again including that, and it goes up as high as a 1. Now, let's move to the x-intercept and the y-intercept. This one, because the line is so big, I know it was a little bit tricky to see. I said that my x-intercept was at the 1, 2, 3, 4, 5. That's what I said. Okay? So the x-intercept is at the +5. And how would I write that? I could write it, if I wanted to write it as an ordered pair, I would say it's at the 5 and 0. Remember that the y will always be 0 on my x-intercept. And then my y-intercept was at the -1. Okay, and so we always have a 0 on the x. If I had to write that down, what this is, that point right there is 0 and -1. Okay, now it's going to be easier for us to figure out what the slope is. So if I want to figure out how it's changing on my y and how it's changing on my x, I'm just going to play devil's advocate here, because sometimes you're given 2 points and you're not sure which one is the one that's on the left and which one's on the right. So you just go, well, how do I do that then? Well, that still works. So you just start here and you say, okay, how is it changing from a 0 to a -1? That's going down 1. Okay, think about it on a number line. From a 0 to a -1, it's going down 1. And then because I started here and went this way, I'm also going to go this one, start at the 5 and go down to this one. So how is it changing from a 5 to a 0? It's going down 5. Now, if I have two negatives, then I would never write it that way, would I? I would write it as 1/5, which makes sense because this is a positive slope. It's going up ever so slightly. Started low on the left and went up high on the right. Okay? All right, next one. Okay, with this one, let's start kind of doing them a little bit out of order, but that's okay. I like to start with my x-intercept, so let's say that's a 2, and my y-intercept is crossing right here at the 1, 2, 3, 4, 5, 6, 7, 8, at the 8. What would you do if it didn't cross it? Well, you'd have to say not applicable. If your line, your graph line, doesn't cross the y-intercept or doesn't cross the x-intercept, then you have to say so. Now, if it had little arrows on the end of it, then what you would do is you would continue it until it did, because it just means that they're only showing you a part of it, but it does continue on, kind of like this line over here. Even though we know it would continue on because of the arrows, we're not seeing it way up here, but we could get our ruler out and do it that way. So the x-intercept would be with 2 and 0, and the y-intercept would be at 0 and 8. So now, how about our slope? Well, from a 0 to an 8, that's an increase of 8. And from a 2 to a 0, that's a decrease of 2. So what would that turn into? That would turn into a -4, because 8 divides by 2 to give you a 4, and of course it's negative. And that makes sense, doesn't it? Because look, it's starting high and then it's going steeply down. Okay, this is a negative slope. All right, and in terms of my domain, how far over here does it go on my x? Well, the very furthest it goes is the 0. So x can be no greater than 0, but it's going to be it's going to be always less than a 1, 2, 3. And what about the y? The highest that y will go is going to be 1, 2, 3, 4, 5, 6, 7, 8. 8 would go over here. And then the lowest it would go is a -1, 2, 3, 4. Notice if I put it with the lowest number first and then up to the highest number, it's always going to have my inequality signs facing in the same direction. And these ones always have the line underneath because they have a closed dot. If it was an open dot, then I would mean it's not including that. And that's, you remember that from grade 9? All right, and then the last one for number 1. Again, remember what we said about the domain and the range. If they're arrows, they're really kind of the easiest ones because it means this is a continuous line. It's all of the points in between, and because it has the arrows on the end, it would go on forever. So the domain literally can be any number, and it would be eventually. And the same with the range. So x belongs to the real number system, y belongs to the real number system. All right, now what's the x-intercept? It's at the -1, and the y-intercept is at the 2, positive 2. So this would be a -1 and 0, and this would be a 0 and a positive 2. So how's it changing on my y, and how's it changing on my x? Now, I always start over here, right? This is my y. So from a 0 to a 2, that's an increase of 2, a positive 2. And then from a -1 to a 0, that's also an increase, and it's an increase of 1. And so what does that turn into? It turns into just a plain old 2. Okay? All right. Number 2. Please circle which of the following linear relations has a slope of -2/3 and a y-intercept of 4. All right, so first of all, we can start with all the ones that are negatives, and those are potential ones. So this guy is a negative slope, this is a negative slope, and this is a negative slope. But this guy right here is a positive slope, so there's no way it can be B. There's no way it can be B. All right, so now let's look at the fact that it has an intercept of 4, positive 4 on the y. So this is a 1, 2, 3. Oh, no, this isn't a 4, so this can't be the one. This one down here, 1, 2, 3, 4. So it could be this one. 1, 2, 3, 4. It could be this one. So it's between C and D. Okay, and they're both negative slopes. They both have a y-intercept of 4. Now we're going to have to actually determine what the slope is. And I think probably the easiest way to do that is to use our intercepts to be able to figure out how it's changing. So let's see, how is it changing from here to this point right here? So it's going down 1, 2, 3, 4. So it's going down 4, and it's going over 1, 2, 3, 4, 5, 6. So that would of course reduce to a -2/3. So that one actually works. Let's just make sure that this one wouldn't work as well. So we've got -1, 2, 3, 4, down 4, and then over 1, 2. No, that's going to have a slope of -2. So that one doesn't work. It's C. Okay. Use graph paper and a ruler to construct a graph for each of the following statements. All right. It has a slope of -3 and a y-intercept of 4. A slope of -3 and a y-intercept of 4. So I've got this neat graph paper like this that I'm going to use. And so I'm just going to write this on here. 3a is going to have a slope of -3 and a y-intercept of 4. Okay, so I always start with a point. I can't just start putting in my slope. I have to have my point first. So my y-intercept is my point, my first point. And that generally is the case. So 1, 2, 3, 4. Okay, and then my slope is a -3, so it's going to go, and if it doesn't have anything on the bottom, it's definitely a +1. So then it's going to go down 3, 1, 2, 3, and over 1. 1, 2, 3, 1. 1, 2, 3, 1. Just like that. Notice how they're in a nice straight line. Take my ruler, don't try to eyeball it, and connect the dots. So a -3, first of all, high on the left, low on the right. So that part's good. And look at how steep it is. Can you imagine trying to do that as a roof or something like that? That would be incredible, wouldn't it? Okay, so or letter B has a slope of +3/4 and a y-intercept of -3. Okay, start with the -3. 1, 2, 3. Notice I'm not labeling in all my numbers. If each line is worth 1, I don't need to. And then from there, it's going to go up 3, 1, 2, 3, over 4, 1, 2, 3, 4. It happens to be my x-intercept. That won't always happen, but it did happen this time. So then connect your dots. And the last one, it says an undefined slope and an x-intercept of 6.5. Okay. So this is C, excuse me, undefined slope. And then my x-intercept, oh, x-intercept? Yep, x-intercept. Careful, I almost wrote down that it was my y-intercept. Okay, so my x-intercept at 6.5, so there's 1, 2, 3, 4, 5, 6 and a half. So right there is my x-intercept. And then an undefined slope is a vertical line. Okay, that's because it has whatever number on the top. Okay, so you've got your change in your y is going to be whatever, but then the change in the x is always going to be a 0. So it's always a divide by 0. So it looks like this. It's got lots of rise, but no run. And it's a straight up and down line. This is what an undefined slope looks like. Okay? Think about this on a calculator. If I put in that it was changing on my, let's say it was changing on my y by 8, let's say, and then it's not changing on my run, so it's going to divide by 0, no 0 change. What happens? This little e over here stands for error, and mathematically that means it's undefined. Undefined, okay? All right. Number 4. The cost of renting an air compressor for a day is shown in the graph below. So you got your rental cost is on the y-axis, and then you have the number of hours rented on the x-axis. So the first question is, what is the y-intercept of the relation, and what does it represent in this scenario? Okay, well, the y-intercept is 20. And what does that represent? It represents the starting cost before you've even had it for any time at all. Like there's like a base price. So they might say, there's and they might do that because they want to, take wear and tear on the machine or whatever it is for the air compressor, so they say, well, we have to have a base price of $20. Even if you only rent it for an hour, it's still going to be $20. That makes it worth it to them, makes it worth handling the air compressor, all of those things. So that's what that y-intercept actually represents in this case. And then this is what's the slope of the slanted portion. So this is the slanted portion right here, and then of course it just levels off to a 0 slope up here. So the slope of the slanted portion, and what does it represent? Okay, well, let's go from here to here. Let's look at this point right here. So this point right here is a 0 and 20, right? And this point right here is an 8. And what number is that right there? Go all the way over 8 and 60. Okay, so how is it changing on my y? How is it changing on my x? Slide that up a little bit for you. So it's changing on my y from a 20 to a 60. That's an increase of 40. From a 20 to a 60 is an increase of 40. Always do the y first. And then from the 0 to the 8 is an increase of 8. And so what I would do is I would write that down in my lowest form or reduced form, and that's going to be a 5 over 1 because both of those will divide by 8. And you end up with 5. And what does that represent? What does this slope represent? Well, that represents the cost per 1 hour. So that's the cost, money, per 1 hour of rental. All right, and then it says, what is the slope of the horizontal line segment? Well, anytime you have a horizontal line segment, like this one right here, anytime, that's a zero slope. So we don't even have to figure that anything out. It's just the horizontal slope is 0. Not undefined, it's a 0. And what does this represent? Well, this would represent the fact that it won't go up any higher. So 60 bucks is the highest it's going to cost, and then it's going to level off. And they're saying, you know, there's a maximum price. The max cost of renting the machine per 10 hours, of course. All right. Then it says, what's the range of this relation? The range. So that means, you know, how far down is it going to go on my y, and how far up is it going to go on my y? All right. So the very lowest it's going to be is a 20. That's the very lowest. And we just said that it goes to a maximum of 60. That's the highest it's going to go. So my range, I'm going to write that down.
At this time, if you could...
So sorry about that. We got interrupted. It is school, I guess. I'm here at the school now, so sometimes they get on with the announcements. All right, so as I was saying, when we write down the range, we're going to say, usually with set notation, I write it like this. Let me just slide it up there for you a little bit. So I say, okay, the very lowest it's going to be is the 20, but it can include 20 because it's got that dot, and then the highest it's going to be is going to be a 60. That's my range. What does that represent? Well, think about it. It's the cost of the machine, because that's what this variable represents over here. The y on this particular axis is rental cost, right? So the cost will go no lower than $20 and no higher than $60. That's what my range represents. Okay? All right, and then finally the domain. So, of course, you can rent it for no hours, so 0 hours up to a max, I'd say, of 10. You must have to bring it back after 10 hours. Let me show you that again, sorry. The lowest you can go is, of course, 0 hours, but then you must have to bring it back at 10 hours. I'm guessing that's considered a full day, and maybe then it starts all over again. So the domain is going to be 0 up to 10 hours. This is the lowest is, of course, 0 hours up to a max of 10 hours. Does that make sense? Okay. I kind of actually find that these kind of questions actually make more sense, and it helps you understand what they're doing with the slope, what they're doing with the range, what they're doing. Why are we talking about all these things when they... That never happened when I was at home, did it? All right. Maya jogs on a running track. This graph shows how far she jogs in 10 minutes. Okay, so whenever we have a distance over time, what is that? Distance over time. Now, how many of you had science before this all went down? You know that a distance over time is what? Speed. This is a speed graph. Okay, it's a very common kind of graph. So anytime you have distance and time, time we'll always find is going to be on the x-axis, and then the distance will always be here on the y. And that's because time is your independent variable. You can't control time, right? Time is independent, and then the distance will depend on how much time somebody has gone. Okay, so it says determine the rate of change in this relation. Remember, we said the rate of change is because they call it a rate of change and not just calling it a slope. because of how it's measured. We've got meters and minutes, so we have two different types of units that are being used, and that's what makes it a rate. Okay, two different types of units. Whereas when we're talking about just regular slope, even though we're talking, the formula is the same, usually the units are the exact same. So they might be in, whatever, just numbers and numbers, or hours and hours, or whatever it might be. But it's called a slope, just a regular slope, if they have the units the same. If it's a rate, it's because the two units are different. So determine the rate of change. So that's still going to be change in y over the change in the x. Okay, how is it changing? So I always find it easier to look and see which ones are really, really right at a y line and an x line. So that's a really clear point, and that's a really clear point. In order for me to be able to do this, I have to find two really clear points. I would say that one right there is a really clear point too. So you could use that one if you wanted to, but I wouldn't be able to tell you exactly what the ordered pair is for that point right there or that point. Those are really hard for me to figure out because it's in between. So find one that's nice and easy. This is clear, clear, and clear. Okay, so watch. So I'm going to say, how is it changing from this point to this point right here? On my y, it's going from a 0 up to a 1200. So that's an increase in 1200. And then how is it changing on my x? So from a 0, it's going to a 10. That's an increase of 10. Okay. Now can I reduce that? Absolutely. They both have zeros on the end. So I'm going to cancel both of those out, and that's 120. What is it? Meters per minute. What does that represent? It represents, we already said this, her speed. It represents Maya's speed of 120 meters per 1 minute of running. That is what it represents. Okay, so there's your basic section. So now we're going to move into the mid-range. So it says sketch a linear relation for each of these statements. A linear relation, a line, a graphing line. So I'm just going to start with a Cartesian plane. Okay, so here's my x and here's my y.
Christine Furrow and Susan Brown.
Okay, good land. How many times would be interrupted? I apologize. All right, so it wants us to have a positive x-intercept and a negative y-intercept. Well, all my positive numbers on my x are over here, and all my negatives are over here. On my y, these are all my positives, and then these are all of my negatives, because this point right here in the middle is known as my origin. It's a 0, 0. Everything above, just like on a thermometer, is positive. Everything below is negative. And then just like on a regular number line, these are all positive and these are all negative. So basically what a Cartesian plane is you've got two number lines that are intersecting at the origin. All right, so a positive x-intercept, it doesn't have to be anywhere in particular. Just put a point somewhere here on the x-intercept or on the x-axis that's in the positive place. And then a negative y-intercept, so right here, sure, doesn't matter. Anywhere that's negative. And then you're going to connect the dots. And this is a linear relation that has a positive x-intercept and a negative y-intercept. Okay, next one. Make yourself another Cartesian plane. It's just a sketch. This one has to have a negative x-intercept, so right here, let's say, and a negative y-intercept. Sure, right there. What if you put yours a little bit lower on the y, a little bit closer to the origin? Doesn't matter, right? As long as it is a negative x-intercept and a negative y-intercept. Okay, a negative x-intercept but no y-intercept. Ooh, this one's going to be interesting. I wonder how many of you got this one. Okay, a negative x-intercept, so here's negative right here, but no y-intercept. Well, how could it possibly have no y-intercept? Well, it must be an undefined line. So it would have to go straight up and down. Absolutely straight up and down. It would never go across the y-axis if it's an undefined line that is that has a negative x-intercept. Okay. letter D, a positive y-intercept there, and no x-intercept. Well, what kind of a line are we talking about now? This is going to be a horizontal, zero slope. So I've got to make sure that I've got this kind of running parallel with the x-axis. Okay, and there you have no x-intercept ever. It would never cross it, but it has a positive y-intercept, so it is a zero slope. And then this last one was definitely tricky. I wondered how many of you got this one. All right, let's think about this. An infinite amount of y-intercepts. So here's a y-intercept, and then here's another one, and then here's another one, and here's another one, and here's another one, and here's another one, and I could draw all the ones in between. So because of that, I'm going to draw in a different color so that you can see that what we're talking about, if it's going to have an infinite number of y-intercepts, it must be a line that falls right on top of the y-axis. A little bit tricky one, isn't it? Okay. Now, moving on. This was an interesting question. I like this question. Because again, it's kind of real life, isn't it? So it says the graph below illustrates what happened to the volume of water. Where's the volume found? It's on my y-axis. Remaining in the pitcher of water. A picture of water like this, right guys? Let's see if I can draw it for you. How do you like that? It's a great big water pitcher, okay, and probably has a spout like this. It's actually not a very great pitcher, but whatever, you know what I'm saying. So this is a pitcher of water, and so down here on the x-axis, you're talking about the time that's going by. While this family, the Johnson family, is sitting down at a restaurant. And this line right here represents the volume of water over that course of time going on, okay? So they want us to know, or figure out, what is the meaning of the x-intercept and what is the meaning of the y-intercept in this situation. Okay, so the x-intercept, let's start with that one. That's this one, this guy over here, okay? So my x-intercept is going to be at the end of the meal when there is clearly no volume left of, in the pitcher. There's no volume of water in the pitcher, and it's at the end of the Johnson's meal. So that's the x-intercept. So no volume of water at end of meal. That's what the x-intercept means. The y-intercept then must mean, here's my y-intercept where it's crossing my y. This must be the beginning of the meal when the water pitcher was full. Beginning of meal with full water pitcher. That make sense? Okay. What happened between B and C? All right, so here's B and C. What's a reasonable thought? Well, to me it looks like there are 4 people who poured out some water. So, you know, and it wouldn't take hardly any time. That's why it's basically straight down. So it's just kind of like quick pour and then stop for a second. Go to the next person, quick pour, stop for a few seconds, quick pour, stop for a second, quick pour. So that's a reasonable explanation. Can we be sure that that's what's happening? No, but that's a reasonable explanation for what was going on. Okay? It probably wouldn't be a reasonable answer to say, you know, it was a pour and then the person, like, you know, drank it really quickly and then filled it back up and then drank it really quickly and then filled it back up. Like, that wouldn't seem as reasonable, would it? So let's say down here for B, a reasonable explanation is 4 people had their glasses filled. with water, right? So, and of course this is the water pitcher, would have started out full, and then after the waitress has filled 4 different water glasses, now look, she's got way less volume in her pitcher. Okay, then it says between D and E. Well, the waitress must have come along and either refilled the water pitcher. That'd be my guess, because it doesn't say that it's a different water pitcher. So I'm guessing she didn't just go and get them a new one. But this is, her taking it and refilling it. So the waitress refills the water pitcher. Okay. What is the meaning of the horizontal line segments? Well, like here and here and here. Like nobody's touching the water pitcher. Like it's the volume of it is just staying. So it's just, sitting there on the table. Sitting there on the table. Sitting there, in all those cases, the volume isn't changing, but time is going on. So what's the meaning? The volume isn't changing. So no one is pouring water for a short period of time. Yeah, just sitting there on the table. All right. What possible unit could you use to measure the numbers in the range? Well, this is the range over here, right? So the right here, if we're talking about volume, would it be reasonable to think that we would be talking about, liters? Would we be talking about 1 liter, 2 liter, 3 liter? How big of is a water pitcher? Well, a water pitcher probably would only be maybe 1 liter, 2 liters or so. It's not going to be much more than that. So it would be more reasonable to think, if we're way up here on this graph, this is probably milliliters. So I would say a possible unit would be milliliters. Okay? And then what possible unit could you use to measure the numbers in the domain? Well, how long does it usually take, to sit and have dinner? Well, it's not going to be like 1 hour, 2 hour, 3 hour. That's not reasonable. This is probably in minutes, right? All right. All right, so you're done with the high question. And then the last one. Number 2, it says, the following graph shows the distances covered by 3 joggers during a 2-hour period last Saturday morning. And again, we've got a distance and time. So what is this? This is a speed graph. I said it was common. We've seen it twice in this set of targets. All right. So, which jogger ran the fastest? Well, the easiest way for you to be able to tell which one ran the fastest is look for the steepest slope. These are all they're all increasing, okay? So when I look at this one right here is steeper than this one right here. Look at this guy, it's a little more flattened out, even though he starts here, okay? And then this one right here is even more flattened out. So this guy is the steepest. So even though he started at a different location, he started at a distance of 0 kilometers, whereas this guy obviously started, a little closer to the finish line. This guy right here had to run faster. That's why the slope on it is steeper. So who ran the fastest? B. Now you could actually take some time and figure out what the slope is, but it didn't ask you to do that. It just said, just determine which one's the fastest. And that's the easiest, most reasonable way to do that. Just figure out which slope is the steepest. Think about it like, probably if you think about it like in terms of like if it was a hill that you were climbing, which one would be the hardest hill to climb, right? This guy right here is definitely the steepest hill over this one, and then this one, A, is the easiest one, isn't it? All right, which jogger was the slowest? Well, that's the slowest guy right there, this guy right here who has the least steep. He's kind of running the slowest. He's covered the least amount of distance over the longest amount of time. And I'm not judging because that would be me, but all right. Did any joggers ever pass each other? And how do you know? Well, look at this. So like Jogger B and Jogger C, excuse me, look, they cross each other right here. And then Jogger B and Jogger A cross each other right there. And then Jogger A and Jogger C, they cross each other right there. So how do we know? The lines intersect. Yes, they did. The lines intersect. That shows that they've crossed each other. Okay? Explain the significance of the different Y-intercepts. And I kind of alluded to that at the beginning of this question. So this means that Jogger B started at, distance 0, whereas Jogger C started at distance, and what would these all be? This is, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Not a nice increment, but so approximately 2 kilometers away from, let's say this is the finish line, or the starting line, excuse me. He starts at the starting line. He has a head start. This guy, Jogger C, he has a starting, he gets 2 kilometers head start, and then Jogger A gets a, like 6 kilometer head start. So he didn't actually go as far as what Jogger B did or Jogger C did, because he had a head start. Okay? So the significance of the different Y-intercepts is they all had different starting places. Let's say Jogger B, 0 kilometer head start. Jogger C, approximately 2 kilometer head start. So he's that much closer to the starting line, and then, or to the finish line, excuse me. And then Jogger A has approximately 6 kilometer head start. Does that make sense? Okay. Okay, grade 10. So that's the last video for now. If there's anyone who is looking for more work this week, and you're all set and you have got everything caught up, I know some of you are really trying hard to get work done in other classes as well. So, but if you're ready for more work from me, I can certainly put one more lesson on. There's lots of stuff that we could be doing. So, but I also recognize that this is the last week of classes, and everything is due for June the 12th, which is this coming Friday. So if you, and I don't know if some of you might even have a class or two that you're working on for credit because of your grade 11 biology or whatever it was that you're working on. So just if you want to put something on the team chat that says that you're ready for more work, then I certainly can throw something up for you in particular. If not, this represents the last video for you. And I hope that you have a wonderful summer, and that I am hoping and praying that I will see you in the fall.